So I'm doing position 1, and our givens are our height, which is 0.83 meters, our mass of the ball, which is 0.00552 kilograms, and our gravity, which is 9.8, and we know our velocity is 0 meters per second because it is at top and is not moving. So we are going to find our potential energy, and so we'll take 0.00552 times 9.8 times 0.83 to get a GPE equaling 0.0449 joules. So now we have to find the kinetic energy, which equals 1/2 mass times velocity squared. So KE equals 1/2 your mass, which is 0.00552 times 0 squared, which would cancel it all out, making it 0. So KE equals 0 joules. And then your ME equals your GPE plus KE. So your ME would equal 0.0449, which will be the same ME through the whole thing.
I'm doing the calculations for position number 2. And in this, we know the mass is 0.00552 kilograms. We know the height is 0.75 meters. And we know the acceleration of gravity is 9.8 meters per second squared. And we're going to start by finding the gravitational potential energy. And you do that by multiplying mass by the acceleration of gravity by the height. And when you plug in those numbers, you get 0.0405 joules. Next, we're going to find the kinetic energy. And a way to do this is to subtract the mechanical energy and the gravitational potential energy. If you do that, kinetic energy equals 0.0044 joules. And then after this, we're going to calculate the velocity. So you plug in the kinetic energy to the equation, 1/2 mass times v squared. And when you plug in those numbers, you get velocity equals 1.26 meters per second. And finally, to calculate the mechanical energy, you're going to multiply the you're going to add the gravitational potential energy by the kinetic energy, and that equals to be 0.0449 joules.
Okay, so I did position 3. Our givens are the mass is 0.00552 kilograms. The height is 0.54 meters. And gravity equals 9.8 meters per second. We don't know velocity yet. We do not know mechanical, and we don't know kinetic. For GPE, the equation is m times gravity times height. That would equal 0.029. For kinetic energy, you would have to do the mechanical minus the GPE. From the two other positions, we discovered that the mechanical is 0.0449 joules. So kinetic would equal 0.0159 joules. The equation for kinetic is 1/2 times the mass times the volume squared. Kinetic is 0.0159, set that equal to 1/2 times the mass times velocity squared. Velocity squared equals 5.761. Find the square root of both. It's 2.4 meters per second. And then ME, just to confirm, would equal GPE plus the kinetic, which ultimately equals 0.0449 joules.
So I'm going to be doing position number 4. And to start off, we know the mass of the marble was 0.00552 kilograms. The height was 0.32 meters. And the acceleration of gravity is 9.8 meters per second squared. So I'm first going to calculate the gravitational potential energy by multiplying mass times the acceleration of gravity by height. And when you do that, it calculates to 0.0173 joules for gravitational potential energy. Next, I'm going to calculate the kinetic energy, and you do that by minusing mechanical energy and gravitational potential energy, and that gives you a kinetic energy of 0.0276 joules. Now, using this kinetic energy, I'm going to plug it into the kinetic energy equation to solve for velocity, and that is kinetic energy is equal to 1/2 mass times velocity squared. And whenever you plug in the numbers, velocity is equal to 3.16 meters per second. And finally, I'm going to calculate the mechanical energy by adding the gravitational potential energy and the kinetic energy. And when you add those, mechanical energy is equal to 0.0449 joules.
So I have position 5, and we know that the mass is 0.00552 kilograms, the height is 0.4 meters, and gravity is 9.8 meters per second squared. We're finding kinetic energy, velocity, and mechanical energy. So first, to find the GPE, you do mass times gravity times height. And so that's 0.00552 times 9.8 times 0.4. And so then you get the GPE as 0.0022 joules. And then to find the kinetic energy, you do the mechanical energy minus the GPE. So you get KE equals 0.0449 minus 0.0022. And so the KE equals 0.0427 joules. And then to find the velocity, you do KE equals 1/2 m velocity squared. So you get 0.0427 equals 1/2 of the mass, 0.00552, and the velocity squared. And when you solve that, you get the velocity as 3.93 meters per second. And then to find the mechanical energy, you get the GPE plus the KE, and that is 0.0022 plus 0.0427, and the mechanical energy equals 0.0449 joules.